Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for my calculus students. It's a question on optimization and it's found in the textbook on page 215. Here's the question. A truck crossing the prairies at a constant speed of 110 kilometers per hour gets 8 kilometers per liter of gas. The truck loses a tenth of a kilometer per liter in fuel efficiency for each kilometer per hour increase in speed. Drivers are paid $35 in wages and benefits. Fixed costs for running the truck are $15.50 per hour. If a trip of 450 kilometers is planned, what speed will minimize operating costs? So the first thing is obviously there's a whole bunch of information being thrown our way in this question. So let's look at it really carefully and really piece out what the important information is. So the first thing obviously is that we're trying to minimize the operating costs. So that's how it fits into our optimization unit. It is a question where we're going to have to create some sort of equation and then minimize that equation. So what information do we have that pertain to the cost of this trip? So let's start again. A truck crossing the prairies at a constant speed of 110 kilometers per hour gets 8 kilometers per liter of gas. So this information here pertains to how much gas this truck is using as we're driving. So every 8 kilometers, the truck is using 1 liter, and that exists only at the speed 110 kilometers per hour. But if we increase the speed, the truck loses 0.1 kilometer per liter in fuel efficiency for every 1 kilometer per hour increase in speed. So we have a fuel efficiency right now if we go 110 kilometers per hour, but if we change that, then we can hopefully increase fuel efficiency, use less gas, and therefore reduce the price. One thing that's missing on here, and it's my fault, I didn't type it, is the fact that we know that gas right now is costing 68 cents per liter. Now, when I say right now, I mean at the time the question was written. If you can find me a gas station in Toronto with that price gas, let me know. Okay, so we have all of this information here. So I'm just going to do the whole thing here. This is all information about the cost of the fuel efficiency. So we know that it costs money, this much money per liter of gas, and at certain speeds we're using fuel at a certain rate. So we have all this green stuff which has to do with fuel efficiency. And then as we keep reading, we're now talking about the fact that drivers are paid $35 per hour, and the fixed costs are $15.50 per hour. So both of those blue pieces of information relate to the cost per hour of the trip. And then we know, of course, that the trip is 450 kilometers per hour. So we have sort of the purple there representing sort of general information that we're going to use. The blue information is about the cost per hour, and the green information has to do with cost relating to the use of gas. So let's look at that fuel usage a little more carefully. So we know that the truck is crossing the prairies at a constant speed of 110 kilometers per hour. And I'm just going to add here that we know that it's 68 cents per liter of gas. So, but what's important here obviously is that we are going to change the speed and therefore impact the fuel efficiency. So if we drive faster, we'll get there sooner. That'll help with our cost per hour. But every time we increase the speed, we're losing fuel efficiency, which means that we need more gas to go further. So I'm going to let x, this is where we need to introduce some sort of variable. I'm going to let x be the increase in speed. So every x represents 1 kilometer per hour that we're going to go faster. So that means my new speed is going to be 110 plus x kilometers per hour. That's how fast that we're going to drive the truck. That's our speed. But every time we increase by 1 kilometer per hour, so every time we go up by 1 in our speed, we lose fuel efficiency. So in other words, for 1 liter of gas, we're going to go slightly fewer kilometers. So those are the two things that involve a variable called x. So let's talk about then how we use this information to find the cost. So we know that the cost for fuel is 68 cents per liter, so we need to figure out how many liters of gas will be used. So the fuel usage, this is the information we have about fuel usage. This is how much fuel we're using. We're using 1 liter of gas for every this much kilometers. And we know that in total, no matter how fast I go, I have to go 450 kilometers total, and that allows me to set up a proportion. So I know right now that this is how many kilometers I can get on 1 liter of gas. It's that 8 minus 0.1x that we developed earlier. And I need to go 450 kilometers. So therefore, using this proportion, cross multiply, whatever you like to do, we can figure out how many liters of gas it'll take to go 450 kilometers. So when I did this, I got that I would use this many liters of gas. And obviously, there's an x in it, so it's hard to say, oh, you need 450 divided by 8 minus 0.1x. That's confusing, but that looks good. That's how many liters of gas I need for this trip. And because it's 68 cents per liter, then I can multiply that by 68 cents. So, and that leaves me with this little expression. This is the cost of gas for the trip, because I took the number of liters that I need based on my fuel efficiency, which was up here, and multiplied that by the cost of the fuel. So this 306 divided by 8 minus 0.1x is the cost of gas for the trip. But of course, there's more information than that. So we also need to consider the wages and fixed costs. So it's $35 per hour in wages and benefits, $15.50 per hour for the cost. So they're both per hour, so we're just going to combine them together into $50.50 per hour. So we now need to think about how many hours will the trip take. So we know that we have a certain distance that we must travel, and this is the speed I'm traveling at. And so if we use the fundamental relationship about speed, distance, and time, and rearrange it, I know the distance is 450. Oops, little pen problem here. I know that my distance is 450. I know that my speed is 110 plus x. Therefore, this is how much time it'll take me to drive 450 kilometers at the speed I've set. So that's how long it'll take. And of course, every hour costs me 50/50. So this is the time in hours, this is the cost per hour. So multiplying them together, I get that the cost per hour, the total cost of the trip is right here. If we look only at the wages and set costs. So now I can combine them together into one formula that represents the cost of the trip. This is the cost because I have to put gas into the vehicle, and gas is spent based on my fuel efficiency, and fuel efficiency is that number that decreased a little bit because I was speeding up. This part of the equation represents the cost per hour. So this is the total cost because of gas and the total cost because of time. These are both expressions that are the cost of the trip, the cost of the trip. So this is now the total cost of the trip. So this is the formula that we need to use in order to find the optimal value of x to reduce as much as possible the cost of the trip. But before we do that, let's look at the restrictions on x. So pretty straightforward. Fuel efficiency cannot be negative. So we can't gain gas somehow, although that would be wonderful. So the fuel efficiency, which is this little bit here, we can't let that particular value be less than 0, because that would again mean that we were somehow getting -2 kilometers per liter, and I'm not sure what that means. Every liter of gas, I'm going backwards, or am I getting gas? I don't know. Doesn't make sense, so we can't let that happen. So we know that we can't let x be below 80. Similarly, we can't have a negative speed. So we can't slow down so much to increase fuel efficiency that we go backwards. Again, doesn't make sense. So we take the speed amount and we say speed has to be positive. So those are my restrictions. So here's the question now as a purely algebraic exercise. I need to minimize the cost equation based on I'm only allowed to look between -110 and 80 for x. So this is the equation that we need to take the derivative of so that we can find critical values and test them. So I'm now going to switch from, I'm going to start writing instead of typing, because it's a lot easier to write math than it is to type it. So here's the equation that I have. The cost is, and I guess I've reversed on my sheet of paper that I'm using to guide me, so I can catch mistakes pretty quickly. So I've reversed sort of the order of the two terms, but I'm sure that's acceptable. Again, I'm having some issues with my pen. Blah, blah, blah. Technology. It's actually I know what I'm doing wrong, but too late. Okay. There's the equation, and I need to take the derivative. So to take the derivative, the first thing I'm going to do is write this so that it doesn't look like I have a quotient. So I'm going to take the denominators and I'm going to move them into the numerator by giving them that negative exponent, just because it allows me to use the power rule. Well, I guess I have to use the product rule, but I just prefer to do this. And so now I'm going to take the derivative of this function. So I have negative 2, I forgot an equal sign. So -1 times that coefficient. And then the bracket doesn't change. Subtract 1. And multiply this by the derivative of the bracket. Well, the derivative is 1, so pretend I did. And I did. So then we have -1 times that coefficient. That's what the bracket is. Subtract 1. And then over here, I do have a derivative in here of -0.1. So I've taken the derivative, and now I need to do something with it so that I can actually set it equal to 0 and find those critical values. So let's write this in a way that makes me happier. What would make me happier? So -22725 over 1110 plus x squared. And then I'm going to take, I'm going to take this number times this number, because they're both just multiplied together. That, of course, is protected by the exponent, so I can't include that. So -306 times -0.1 is positive 30.6. And of course, the negative exponent means I'm going to rewrite this in the denominator with positive exponent. So that's the derivative of the cost function. And now I need to set that equal to 0 so that I can look for those critical values. So 0, oops, forgot the negative. Let me just erase. So 0 equals -22725 over 1110 plus x squared. Now at this point, if you're still watching, the hardest part of this question obviously was just getting the equation correctly. This is now just an algebraic exercise. Also an exercise in how many mistakes can I make here. Okay, so -0. See, I'm now at the point where I don't want to stop and correct through editing. Like, I just noticed a mistake I wrote over here. I'm having RAM difficulties on my computer. It doesn't like it when I do this, and then I noticed I did that wrong, so bear with me. Okay, so that should have been like that, and that should be like that, and I apologize for how messy this is getting. Okay, so now we just have to do this algebraic exercise. Solve for x. So I'm going to take this entire term, which right now is negative, and move it to the left-hand side of the equation so that it will be positive. And of course, when I say move it to the left-hand side, what I mean is add it to both sides so that it's eliminated from one side and now exists in opposite polarity on the other side. How do you like that fancy math talk, huh? All right, so there it is. And this allows me to say, okay, well, now I can see an approach. I'm going to cross multiply, and then I won't have any more denominator problems. So 22725 times 8 minus 0.1x squared equals 30.6 times 1110 plus x squared. And so now hopefully you see that what I want to do here. Now I could divide both sides by 30.6. I'm just going to change color to sort of, I don't know, it's getting boring in blue. I'm going to divide both sides by 30.6, so I only have one side that has, like, a number out front, and I'm in decimal mode anyway, so, oh look, I didn't change colors. Thanks, computer. And then I'm also going to expand this binomial right here, and I'm going to expand this binomial here. So I don't know if I'm going to have room to do all of this. I don't know if you need to see it, but here it is. So square the first, double the product, square the last, and then square the first, double the product, square the last, and then I'm going to expand by multiplying that in so that I can then move everything to one side of the equation, and I'll have a quadratic. And excuse me, what you end up with, where is it, is this quadratic, 6.426x squared minus 1408.16x plus 3542.6.4 equals 0. Use the quadratic equation and you can solve for x. You get two answers. X is 190. That is not allowable in my interval. And I get x is 29. So again, we need to... I'm laughing. I don't know how many of the glitches are actually showing up in the video. Gosh, I hope the video is working. So now, again, I can't test that one because I needed to look between negative 80. Well, no, I need to look between negative 110 and 80. So I'm going to test the cost at negative 109. I'm going to test the cost at 29, and I'm going to test the cost at 79. So 29 obviously is a critical value that I just found by doing the derivative, reverse derivative, set it equal to 0. And the negative 109 and 79 are because I can't sub negative 110 into my formula. That would cause a bad math situation. And I can't sub 80 in because that would be bad. So I'm going to go close to them and just double check that I'm not, I don't have one of those situations where actually either the truck should basically crawl along at no speed or the truck should go ludicrously fast to the point of breaking land speed records. So in the original equation, I'm going to sub negative 109 in, and I'm just going to tell you what I get. I get $23,012.10. Ooh, that's a lot. If I sub 29 in, I get $180. That's better. And if I sub 79 in, I get $3,180.23. So I don't know about you. Pretty clearly, if I let x equal 29, I have the minimal cost. So I believe the question was, what is the minimum speed? Bear with me, I'm just going to double check. What speed will minimize operating costs? Boom. So the answer is 110 plus x. We just discovered that x is 29. So the driver should drive at 139 miles per hour. Sorry. Wow, 139 kilometers per hour. But, obey speed limits and drive safely, everybody. That seems a little fast. All right, I hope that was helpful. Sorry for all the glitches.